Welcome back to math class. This is Mrs. Witt. This is lesson 14.3 about inequalities, and we will be writing inequalities that represent real-world problems. Let's begin by just recalling some things that we already know. A variable is a letter or some kind of character or symbol that represents an unknown value, and a constant is a number. It doesn't change. An equation is something that we set equal to something else. An inequality is like that, but it has these symbols, right? And what do those symbols mean? Well, it means less than, greater than, less than or equal to, greater than or equal to. A solution is a value that makes that equation or that statement, that makes it true. And last lesson we talked about inverse operation. That's kind of like the undo. It's the opposite operation. So if it says addition, the inverse would be subtraction, and that goes both ways. And if it's multiplication, the inverse is division, right? So the inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division, and the inverse of division is multiplication. So in a previous lesson, we discussed about how we use variables to represent quantities in real-world problems by writing equations. That was back in 14.1. So what if we're not looking for a specific exact quantity? What if we just want to find more than something or less than something? Take a minute to think about that. In situations like that, we're not going to say that an answer is equal to something or that we're looking for exactly something. We're going to be using symbols like this, which means less than, like this, which means greater than, and then if we have part of an equal sign under it, then we know that it's going to be less than or equal to. And same thing the other way. If it's got part of an equal sign under it, if half of it is a greater than and half of it is an equal sign, then we know that that value is going to be either greater than or equal to. So let's try that in an actual problem. Kirsten wants to take a Disney cruise when the pandemic is over. By the way, Kirsten is my daughter. She's obsessed with Disney. Kirsten wants to take a Disney cruise when the pandemic is over. This is a good time for her to save money since she doesn't spend much of her entertainment budget right now. She researched and found that she can go to the Bahamas for about $1,500. She wants to be sure she has enough in case prices go up. So she wants to save more than $1,500. Her entertainment budget is $100 each month. Write an inequality that represents how long she will need to save her entertainment budget to have more than $1,500. Okay, so what is it asking? It's asking how many months before she has more than $15. So let's use M as our variable and say that M is the number of months that she will save her entertainment budget. Okay, that's a lot of words, but it's the number of months. Let's find some important information. Well, let's see, we know that she wants to save more than $1,500, and her entertainment budget is $100 each month. Okay, so let's put that information together. So we know that she's going to save $100 each month, right? So 100 times the number of months, and she wants that to give her more than $1,500. We could put our dollar signs in there if we wanted to. I'm not too worried about it right now. But does this make sense? Well, if she saves $100 every month, how many months will it take for her to have more than $1,500? I think that sums up the situation exactly. So now why don't you try? Jason's basketball team is selling raffle tickets to raise money for new equipment. Each raffle ticket costs $4. The team needs to raise $853. What is the fewest number of tickets they need to sell to meet their goal? Well, before I send you loose to do this on your own, I want to explain the fewest number of tickets. So if that is the absolute littlest amount they can do, that means what they really want to know is that they need to have more than that number, okay? So think of this when it says fewest. That's the least amount that they can have. So they really want more than, which means you're going to be looking for the greater than symbol. Greater than or equal to. Okay, so that's a little bit confusing, and even to me now, I really have to stop and think about it. So I'll give you a minute to work on that on your own. Okay, so let's start by defining our variable. So let's say T, because we're talking about the number of raffle tickets they have to sell. So a little trick I want to tell you too, when I make my T's for variables, I make sure I give them a little tail on the end so that I don't confuse them with a plus sign, okay? So if each raffle ticket costs $4, let's find some information here. Each ticket's going to cost $4 and they need to make at least $853. So if we do that, we know that I don't want to write in that color. That's hard to see. 4 times, that's $4 for every ticket. And we want that to be at the very least, so we want it to be more than or equal to $853. So again, we can write those dollar signs if we want to. You don't have to for me. All right. So let's kind of recap that really quick. What does a variable represent? Well, a variable can represent any unknown value. I know I've been drilling that in your head, but it's very important that you understand that. And what is the difference between an equation and an inequality? Well, here, let's think about it this way. Okay, so an equation is something that is exactly equal to, right? Because we've got that beginning of the word there, equation is the beginning of the word equal. And what is an inequality? What is an inequality? Well, an inequality is not exactly equal to. It is going to be more, let's not use the word more. Let's use greater than, or less than. And finally, how can we use variables to write inequalities? Well, that's simple. We're going to use them the same way that we did. The same way as we did in equations. We're going to use them to represent a value that we don't know. It didn't magically change what a variable does. This just kind of gives it one more tool in its toolbox. It's like, not, oh no, I don't want to just make it exactly equal to something. I can also help you figure out what's the least number or the greatest number or the minimum amount of this or that, or the maximum of this or that we can do. So equations and inequalities can both use variables in very much the same way.